Hello everyone. So let's discuss the second problem of today's biweekly contest, maximize number of subsequences in a string. So we are given two string, one is of length n, basically 10 to the power 5, and the second string which is of length 2. Now we need to we can perform exactly one operation. The operation is whether we can add any character, basically 0th or the first character to either beginning or end of the string, and then we need to count the number of subsequences of this pattern into the resultant string, and we have to return what is the maximum number of times or maximum number of uh, subsequences with of this pattern into this string. So we need to count how many times this pattern can appear in this string as a subsequence. So let's try to understand this with an example. Let's say this is the pattern AC and this is the string ABDC DBC. So let's first, so we need to perform one operation. Basically, either we can add A to the beginning, or we can add C to the beginning, or we can add A to the end, or we can add C to the end. So we have to perform any of these operation, and then we have to calculate the number of times this pattern occurs into the resultant string. So just for simplicity, let's assume that we have decided to put A in the front of the string. Now let's try to find out how many times this pattern appears into the string. So if we take this character and this character, it's a one time the pattern occurs. Now if we take this character and this character, so two times we have seen the pattern. Now if we take this character and this character, three times the pattern has appeared. If we take this character and this character, again match, basically four times the pattern has appeared. So what we are saying is, basically if we append A, then this pattern appears four times uh, into the original string. Now let's say we already have a function wherein it takes in a string, and it also takes in this pattern of two length. Okay, now it returns the number of times this pattern appears into the string. Okay, now if you have already this function implemented, what else you can do? So basically we have to perform one operation, right? Either to we can choose any of these two characters and append to the string or prepend to the string. So how many cases will be there? Either we can append A to the front, or we can append C to the front, or we can uh, add A to the end, or we can add C to the end. So in total there are four possible combination of this entire string. So we will just iterate over all these four combination and then call this function. So uh, basically if this function is fast enough, this function f. So so for simplicity, let's assume that this is the basically this is the string, and we need to find out how many times AC appears into the string. So how to do that? So we have to count the number of times AC occurs, and we know that it is ending with C, right? So whatever pattern we get, it will either end here or it will end here, right? So if we just count the number of times the pattern will end here, and then we count number of times the pattern will end here, and sum them two, we will get the answer, right? So let's try to calculate for this C. So what we are calculating, how many times in this string the pattern end here. So basically we are saying that we got the C. Now we just have to find out A. So basically there are two A's in the front. So either it can start from here or it can start from here. So there are two possibilities. So total two times this pattern appears into this entire string. Similarly, for C, we will again count how many times A appears in the front of C. This C, there is one more A here. Then for this C, number of times the pattern appears is 2 because there are two A's in front of this C. For this C, the number of times the pattern will appear will be 3 because there are 3 A's in front of this C. So total 2 plus 3 equals to total 5 times this AC appears in this entire string. So for like now, if you look at the approach, we need to find two things. First is uh, we need to fix the last position of the pattern, which is just finding all the C's in the given text, which is fast enough. Basically, we can do that in order n. The second operation is we have to count number of A's in front of these C's, right? So if we just do it in the naive way, for each C, it will require us to traverse through the entire array. So therefore, it will require order and time to compute. So if we do this for every C in the array, total we will be requiring order n square time. But we can speed this up. The thing is, if you look at what we need is how many time A appear in the front of the array, right? So let's do one thing. Let's uh, replace A with 1 and all the other characters will with 0. Now what we want is how many times 1 appears in this entire prefix, which is basically the sum of this entire prefix, which is 2. Again, for this C, what we will want is how many times A appears in this entire prefix, which is equals to how many number of ones this entire prefix has, which in turn is equals to the total sum of the array, which is again 2. So now you can see we just need the prefix sum of the array. If you don't know about prefix sum, I have talked about it in the previous weekly contest. I will link the video in the description below. You can watch it. So basically, for each position, what we want is the sum of all the positions before it. Now, how to calculate it is simply, let's say we have the prefix sum until here. Basically, we have the sum until here, and we want to calculate the sum until here. So, which is nothing but look at the prefix sum and add that entire thing to our answer. So hope the entire solution is clear. So just to reiterate, we will just we will just first iterate over all the C's in the entire array, and then using prefix sum, we will calculate how many A's are there in the front of the array. And with this, we will need, so to calculate prefix sum, we need order and time, and then we will iterate over the entire array to find out C, which in turn again require order and time. So total in order and time, we will be able to implement this function f. And if you remember, our original question was to we can append A or C either at the beginning or at the end. So we will try every possible combination, and there are only four possible combination. So we will just call this function four times, and then we are done. Now we can further optimize. Basically, instead of calling this function four times, we can only call it two times. Reason being, it is not at all optimal to prepend C in the beginning, right? So if we just uh, instead of A, if we have put C here, we are sure that it will not contribute anything to our answer, because before C, A is required, right? So we can ignore this C, adding C to the front. Similarly, we can ignore adding A to the end, because we are sure it will not contribute anything, because another C will be required after A. So let's look at the code. I have done the same thing. This is the function that we have implemented. We will go to that. So, but for before that, what I have done is appended the C, basically the last character, or prepended the initial character, and then take the maximum among those two. To implement count, so as discussed, we have to implement the prefix sums. So here, instead of calculating the entire prefix array, I am just taking care of frequency. So if I is equals to the ending character, I will just add this frequency to the array. If I is equals to a starting character, I will just increment the frequency. So this frequency will give me number of times pattern of 0 occurs until this position. So this in turn will give us how many times this pattern appears in this text. Now the assumption here again is the pattern is only of length 2. So hope this solution is clear. There is one fun exercise that you can do. You can remove these constraints from the array, from the question. Basically, now you can think of the pattern can be of any length, uh, and then you can solve the same question. So let me know in the comment section what is your solution, and if you need any hint, I will be able to provide that in the comment section below. So hope to see some answers there. Until next week, goodbye.